So here for example 5, we're going to find your sum of your geometric series. This is a little more explicit where it gives you what your a sub 1 is, your n, and your r. So since you're given your a sub 1 and your n, that means you're going to want to use the formula s sub n is equal to your a sub 1 minus a sub 1 r to the power of n, and that's going to be all over 1 minus r. So you're going to use the same formula you just used in example 4. So let's go ahead and plug in your numbers. So we're going to say we have your first term, which is a 2, minus 2 times 3 to the power of 10, woo doggy, all over 1 minus 3. So if you plug these into your calculator, and you should be, at this point, you should be letting your calculator do almost all your work. That's going to give you a 2 minus 2 times 3 to the 10th power, small number here, 59,049. And that is going to be all over a negative 2. So make sure you use parentheses, because you would want to put the top in parentheses if you're going to put this all together, and then divide by your negative 2. You end up getting the final answer of 59,048. And that's your solution for 5A. Now 5B is a little bit different, because if you look at what you're given your a sub 1 and your a sub n, so you're not going to use the same formula. You need to use instead s sub n is equal to your a sub 1 minus a sub n times r all over 1 minus r. So it all depends on what you are given. So let's go ahead and plug all of our values in here. Your first term is 2,000 minus your a sub n, which is a 125, all times a 1/2, and that is all over 1 minus a 1/2. So when you plug these values in, once again, don't forget your parentheses around the top. This should be even easier to plug in than up here on the top. You can either put 1 minus 1/2 in parentheses, or if you just divide by a 1/2, because 1 minus 1/2 is a half. And if you plug that in your calculator, you should get 3,875. And that concludes your finding a sum of a geometric series.